Okay, today we are looking at lesson 5, solving a triangle. And our goal today is to use the trig ratios or trigonometry to solve for all of the unknown side lengths, angle. So we'll be given measurements, either an angle or a side, and we asked to find the other measurements using trig ratio. But before I go into today's lesson, let's recap what we've done so far. In lesson 1, we looked at the 180 rule. And in the 180 rule, we said that the sum of the angles of any triangle is at 180 degrees. Then we look at the Pythagorean theorem, and we said if you have a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the opposite sides plus the square of the adjacent side. And then we use the trig ratios to find side lengths. So in this case, we would use the trig ratio sine, cosine, and tangent. And yes, the last lesson we looked at the trig ratio to find angle measures. So let's go through each one of these in detail. So remember, the 180 rule simply states that the sum of three angles in a triangle equals 180 degrees. So if we have a triangle, angle A, B, and C, and this is 70 degrees, this is 50 degrees, this has to be 60 degrees, because 50 degrees plus 70 degrees plus 60 degrees equal 180 degrees. So the formula is angle A plus angle B plus angle C is 180 degrees. So if we know any two angles, we can find a third one. Let's look at this same triangle. Just assume we do not know one of the angles, but we know 70 degrees here and 50 degrees. We have A, B, and C. And we want to find the missing angle. So the missing angle, according to our formula, we do is 180 degrees minus the 50 degrees minus the 70 degrees. And that will give us theta. So if you work this all out, we have theta is equal to 60 degrees. That's the 180 rule. It applies to any triangle. And remember, we said there are four types of triangles. We have the isosceles triangle. We have two sides are equal. We have the scalene, where none of the sides are equal. The right angle, one of the angles, is 90 degrees. And then we have the equilateral, where all three sides and all three angles are equal. The next lesson, we looked at the Pythagorean theorem. And in the Pythagorean theorem, it says if we have a right angle triangle, the square of the hypotenuse is equal to the square of the opposite side and the adjacent side. So let's look at which is probably known as C squared is equal to A squared plus B squared. Or this is the hypotenuse square is equal to adjacent square plus the opposite side square. So if we have triangle, And this is right angle here. We have theta, so this is my opposite side. This would be my hypotenuse and adjacent. Let's say this is 4, say, centimeters, and the adjacent side is 3 centimeters. We want to find the hypotenuse, so we can label this as A and B, and this would be C. So we don't know what C, so C squared is equal to A squared plus B squared. So C squared is equal to 3 squared plus 4 squared. So C squared is equal to 3 to the power 2 is 9, plus 4 to the power 2 is 16. So C squared is 25. So C is equal to the square root of 25, so C is equal to 5. So we say that hypotenuse is 5. Now, the same thing would go if you want to find the opposite side. We will substitute the values given into our base formula, which is this one here, and then solve for the missing side. The next thing we looked at is the finding the side length when we really don't know one of the lengths. We're asked to find one of the lengths. So let's look at, so in the trig ratios now, we have to use the trig ratios. And these are the trig ratios I have a slide here, which is opposite sine, which is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So I'll leave this aside here, so as a reference. So that's one of the trig ratios we'll have to use. So in this case, if we know one side, so we can write this, if we know one side and one angle. So we need to know one side and one angle in this case. And this way we can find the unknown side length. By using one of the trig ratios. And referring to one of these here. So I'll put that right beside me here. So I'll be referring to these trig ratios. So let's look at one example. We've done many of these. So if you have a triangle, it's straighter. So if you have a right angle triangle, and this is 72 degrees, and we have to find the opposite side here, and we have the hypotenuse is 29 mm. So we know we have to find the opposite. So we go to our trig ratios. We know we have to find the opposite, and we're given hypotenuse. So opposite and hypotenuse would be sine. So I'm going to use my sine 72 degrees is equal to x divided by the hypotenuse. So x is equal to 29 sine 72 degrees. Use my calculator for that, and always remember your calculator will be in degree mode. Oops. So it is 29 sine 72. And that'll give me 27 point. Oops. Okay. Let's try it again. So here we have opposite over hypotenuse sine. So I think I'm doing a wrong calculation here. Let's see this. So we have 29, should we do this? 29 sine 72. X is equal to 27.58 millimeters. Okay, so that's using triggers to find side length. Now, we can also use the triggers to find angle when you have a missing angle. So let's look at another example where the angle is now missing. So here we have 26, let's call this inches. So this would be 41 inches, and I'm asked to find theta. So we have the opposite side and we have the hypotenuse. So I go to my trig ratio here and see where it matches, where I have the opposite and hypotenuse. Opposite hypotenuse is sine. So I'll use a sine ratio. Sine theta is equal to, opposite is 26 divided by 41. So this is where I use my calculator, and I need it, so I'll have to go to my trusted calculator here. Get this all set up here, so I wouldn't. So in this case, what I'll have to use my second button, because I need to find my, clear this calculator. So I need to find the angle. So press the second button, sine, and 26. And make sure you have the bracket, it's an inverse, a -1 you should see, divided by 41. Close bracket, and I'll press enter, which is equivalent to equal. That gives me 39, so theta, 39.36 degrees. I rounded it up. So far, that's what we have completed. So today, we're going to put all of those knowledge to use, and we are given either two sides or one angle on one side to find the missing angle or missing sides. So let's look at question 1. So just a reminder. So to solve a triangle means we must find the length of the sides and sizes of all of the angles. And usually we're given 3 measurements and have to solve for the remaining 3 parts of the measurements. For example, in this case here, we give a right angle triangle. We know this is 90 degrees. be given 42 degrees, and be given the opposite side because it's opposite this given angle. Now we need to find this missing angle here. Okay. And we have to find the missing side MN and the hypotenuse, which is, this will be the adjacent side in this case. So we can start labeling our sides for now. I'll put this beside here. Remind me, that's my, so let's label the sides. So this is my angle, reference angle. So this will be the adjacent side. Okay. And this is my hypotenuse. So I'll label it hypotenuse. So we can find this missing angle L by using the 180 rule because we know two angles. And so number one, to find angle L, we use the 180 rule. So in this case, we have 180 degrees minus 42 degrees minus, we have our 90 degrees here. And all together, this will give us an angle of 48 degrees. So we can say this is 48 degrees. So I'll put a highlighter there. So we found the first one here. So this is done, 48 degrees. So the next part we wanted to complete is find either the hypotenuse or the adjacent side. Now, by the way, we could use, the reason why I have the adjacent side here, because I'm using this as my reference angle. You could also use this as a reference angle because we know this angle now, and this becomes the opposite. But we'll continue with what we started off at the beginning, which is this adjacent side, and this is the hypotenuse. So let's find the adjacent side. Now, what do we know? We know the opposite side and an angle. So the opposite side, so if you want to find the adjacent side, to find adjacent side. So you want to find the length of the adjacent side. So given theta, which is 42 degrees, and be given, in this case, the opposite side. Which is 13.5 centimeters. And we need to find the adjacent. Let's call that X. So we go to our trig ratios. Here we are. And we have the opposite. We're trying to find a match. We need to find the opposite side. And sorry, we need to find the adjacent side. And we give it the opposite. So where do we have opposite and adjacent? We have a tangent. So we'll use a tangent ratio. So the tangent is opposite over adjacent. So we have tan 42 degrees. Opposite is 13.5 over x. So we have x is equal to 13.5 divided by 10, 42. So get our calculator out. So we have 13.5 divided by tangent. A little bit higher. Tan 42, close bracket, will give me a measurement of 14.99. So 14.99. So we can run it up to 15, but we'll leave it as 14.99 centimeters. So now we can say this is 14.99 centimeters. So we'll highlight that. So part 3, step in here now. Let's put a line across here. We're going to find it hypotenuse. And let's call that h, because we want to confuse with x. So by the way, we can solve this question in a number of ways. We could use a Pythagorean theorem because we have the measurement of two sides. But I'll continue as if we don't know the opposite side and the adjacent side. Sorry, assuming I don't know the adjacent side, but I know the opposite side only. So when I'm given opposite, which is equal to 13.5, and theta 42 degrees, I'm asked to find h by p, which I call h. So I go to my trig ratio and see where there's a match. What's given and what's need to be found. So I'm given opposite, I need to find hypotenuse. So opposite and hypotenuse is sine. So this would be sine theta is opposite over hypotenuse. So we have sine 42 degrees is equal to opposite, which is 13.5. We call this h. So h is equal to 13.5 divided by sine 42. So I'll go to my calculator. Oops. Go over here. So 13.5 divided by sine 42 gives me a measurement of 20.17. So we can run that to 20.18 centimeters. So that's going to be 20.18 centimeters. So here we are. We found all the missing angles and sides of this triangle. Okay, let's look at example 2. So we asked to solve for triangle PQR. So this orientation looks rather odd, but we can turn the page around if you're not too sure. I can actually switch it around and make it look like 90 degrees, but it's still made it look odd. So I'll keep it as it is right now, the orientation, and label it. So this is my 90 degrees, so this will be the hypotenuse, so HYP. Now, they didn't give me any angle, so I will have to use the trig ratios. I'm given two sides. So to begin, I can find the hypotenuse using the Pythagorean theorem. And then I can go ahead and find the missing angle. It doesn't really matter which side, but I could use P or Q. I just have to find one, and then I'll use the 180 rule to find the third. Simple, using the Pythagorean theorem. Let's C, and I'll label this as A, and this is B. So a given side A, which is 28 kilometers, we have side B, which is 32, and I'm asked to find side C. So this is where I'll apply the Pythagorean theorem. So, which we don't know. So we have C squared is equal to A squared plus B squared. So C, we don't know, is equal to A squared, which is 28, plus 32 squared. So let's do each part. So I have 28 squared. And I'll just do it in detail. We'll see 784. Then we have 32 squared. It's 1024. So C squared is equal to 1024 plus 784. Gives me 1808, 1808. So C is equal to the square root of 1808. So C, so I'll find square root of 1808. Oops. Gives me 42.52 kilometers. So I can write this down. The C is 42.52 km. So I'll highlight that. So that's one completed. Now, part 2, I need to find an angle. And I could go with angle Q or angle P. It really doesn't matter, right? But which angle I'm finding. But I'll go with angle P. So find angle P. So this is what I'll go with. So given side. Now, this is where labeling the sides come in. Side A, which is 28 kilometers. Now, side A, I will label it as the opposite side. So side A. So we're given the opposite. And this will be the adjacent. Because notice this side is opposite this angle. And 32 is the adjacent side. So we have adjacent will be equal to 32. And we have to find theta. So we'll use what's given to find the match on our trig ratios here. So we have opposite and adjacent, and that is tangent. So now we use our tangent ratio here. We have tangent is equal to opposite over adjacent. So tan theta, opposite is 28. Divided by 32. Then I'll use my calculator to be second button first. So second tangent. Remember, whenever you have an angle, you have to use your inverse button. Tangent, clear. Second tan, 28. It's my tan button. 28 divided by 32. Enter. If you're using a regular scientific calculator, you'll put your equal sign there. That gives me 41. So theta is equal to 41.1. Looks like 41.16 degrees. 41.19 degrees. So that's our measurement for that angle. So we round it up to 2 decimal places. So now we have the measurement of side C, the measurement of theta. In this case, theta is angle P. And we put angle P here as 41.19. Now we can find angle Q by using the rule, the 180 rule. So find angle Q which is 180 degrees. What is given? We know the 90 degrees here, minus 41.19. So go to our calculator. So 180 minus 90 minus 41.19, 48.81 degrees. So angle Q is equal to so let's highlight it. And now we can indicate our final angle measurement. So we can say angle Q here. .81 degrees. Okay, so recap. Today we used the trig ratio to solve for all unknown measurement in the right angle triangle. So we're given one angle and a side, and we're asked to find the missing angle. So we use the 180 rule. The 180 rule states that if we know two angles, we can find the third angle by subtracting the known angles from 180. Then we have to find one of the sides, and which is we discovered the adjacent side using the tangent ratio. And finally, we find the hypotenuse using the sine ratio. Question 2, example 2, repeat the process, but in this case, we did the reverse. We had to find, we use a 180 rule at the end because we only were given the 90 degrees. We were given two sides. So if you're given two angles, for example, like in the first case here, you immediately use the 180 rule because you know two angles. If you don't know two angles, but you only know only the 90 degree given, then we have to go about finding the measurement of the angle using the trig ratios. And once we're given two sides, it's much easier or quicker to use the Pythagorean theorem to find the missing side. Once you know one of the missing side or all of the sides, we can use any of the trig ratios to find the angles. So your assignment then would be assignment 5. So for the next class, I would like you to work through these 6 questions. And tomorrow, I'll go through each one of them so that you can check your work against the correct answer.